function g of x, and we want a reflection in the y-axis. So the first thing I'm going to get you to do, we're going to underline reflection in the y-axis. Okay? And above that, we're going to write all the different ways that I could ask that same thing. So if I'm reflecting in the y-axis, can you see that that is a horizontal reflection? Points are moving left and right. So above this, we can write a horizontal reflection. If we wanted to write a horizontal reflection in function notation, would the negative be inside or outside of the function? So everything that affects the x, horizontal is affecting the x, that always happens inside the function. So we can write function notation. We can say if I had some function f, the negative would be in the inside of the function. Okay? So it can be asked in a bunch of different ways. One more way that they could ask reflected in the y-axis, sometimes it shows up as reflected over x equals 0. Remember when we were labeling asymptotes that vertical lines were always x equals, horizontal lines are always y equals. So I could say the y-axis with its equation x equals 0. Sometimes it's nice to see all the different ways that someone could say the same thing all at once. So you're like, oh, I know that this is this kind of notation. So we could take a point. Like for example, this point right here is at negative 3, 1. What am I going to do? If the negative's with the x, I'm going to multiply algebraically. I'm going to multiply my x values by negative 1. Graphically, that's going to flip over. So my new point is going to be at positive 3, 1. This point down here, if it got flipped over, would be over here. 3, 0 would go to, 3, negative 2 would flip over to negative 3, negative 2. And 5, 2 would now be at negative 5, 2. Drawing and connecting the dots. Visualizing it in your brain, can you take the red graph and flip it over? The y-axis. Does your brain do that? Some brains are like, no, it gets messy in there when I try. I pick it up, it fell on the floor, it broke. I don't see what it looks like anymore. Other people have that ability to take something like this and say, yes, I can imagine picking it up, flipping it over, and it landing where the green graph is. Some people can only reflect parts of it at a time. They're like, I have no problem taking this half and flipping it over to match that half. I can take half at a time, and then I can take the other half and flip it over. So just different ways that you train your brain to try to visualize things. Okay? This is one of the things that inadvertently math is helping you for the rest of your life. Math causes your brain to do certain difficult tasks. And later on in life, you'll never be flipping graphs, but you might need to, put a key into a lock. And it doesn't fit. And it's not going in. And you're like, oh, I could flip it around. And that's a very simplistic way of looking at it. But you'll have to figure out, figure out how things fit. You might go to IKEA and buy something. And then you get back to your car, and it doesn't want to fit in the trunk. And so you might have to, like, how am I going to adjust this thing? Flip it around. You have to flip it around in your head and make it fit into your vehicle. Okay? The stuff that we're practicing here is getting your brain able to do those sorts of things. Okay. Reread the question. I've sketched the image. Done. State the domain and range of each function. So I'm going to use red for my original one. And in this one, I'm going to use interval notation. So domain are your x values. My smallest x value is at -3 for the red one. The biggest x value is at 5. And square brackets for both of them. My range, my smallest y value on my red one is -2. My largest y value is +2. Then on my green graph, my smallest x value is now -5. On my green graph, my biggest x value is +3. And my smallest y value is -2. And my biggest y value is +2. Notice the range didn't change. Why not? Well, what was the range? The range are your y values. What was the only thing we changed? We multiplied x by -1. If you multiply all your x coordinates by -1, does it make sense? Your y coordinates would not change. So your range stays the same. Multiplying your x coordinates by -1, do you see how that affects the domain? The 5 became the -5, so the maximum became the minimum. And the minimum became the maximum. It's good to see these observations as we go, because sometimes you might get a question that they take out the main part of the question and just start with the domain. There was one in the homework from the other day that was just working with domains, but it was what happens to the domain if you shift it to the left and up and those kind of things. So just noticing some of those things as we go on along. If you go to your homework, above this one, write 3 and 13, quickly circle 3 and 13